So it says which segment is opposite of angle E? And so here's angle E. So what segment is opposite of angle E? Segment JU. Usually when you write a segment, you put a line on the top. And there it is. And JU is the same as UJ. And that's it. That's how simple that is. And then this one here, which says which segment is adjacent to angle R. So here's angle R. And so be careful. Some students wrote RC. And yeah, I guess you can say that's adjacent, but there's a name for that one. That one's called the hypotenuse. So we're not using that one. So which one's adjacent? Yeah, RP. Or you can say PR. Easy, guys. So there's going to be 5 of those questions right off the bat on Delty. And those, I'm okay if you answer those in 2 seconds each, because they really are that simple. So there's no warnings there if you do it in like 10 seconds, 5 questions. All right, here we go. So pretty much all of these illustrations, I have to give credit to Delty because I took them all from Delty. When I say Delty, I mean Delta Math. So I took all the illustrations from them, well, at least these triangles, I took them all from them. And it says, find the value of sine h rounded to the nearest hundredth. So nearest hundredths means after the decimal point, 2 points afterwards. So here's sine h, here's h. So I'm going to write SOHCAHTOA. And then I circle the SOH, or you don't have to, I guess. And then I'm going to write sine of h is equal to, and it's opposite, so I'm going to write 7 over hypotenuse, 25. I actually would prefer that number, but they want it to the nearest hundredth, so that's fine. So I take my little calculator, and I'm going to show you where I got my calculator from, guys. I got it from Desmos. I put scientific calculator, so here it is. And I'm just going to write 7 over 25. And there it is, 0.28. So I go back, and I write 0.28. That's your hundredths place. Pretty simple so far, guys. Nothing crazy. Let's go to the next one. It says, find the value of tan L. So here's L, and tan L is opposite over adjacent. You're going to notice something. You are missing this side. So what theorem can I use to figure out that side there? Yeah, Pythagorean Theorem. We're going to do it in one step. If it confuses, you know what? Let's do it in several steps. Pythagorean Theorem, x squared plus the square root of 77 squared equals 9 squared. I just did a squared plus b squared equals c squared. And if you want, you can always do it in one step. X equals square root 9 squared minus square root of 77 squared. So x equals, let's see what we got here. 81 minus 77. Yeah, it looks like we got a perfect number, so we don't need a calculator for that. The square root of 4 is 2. So I write that down like that. Now I'm finally ready to answer, and I'll slow down, guys. I'm going to write SOHCAHTOA. It wants tangent, so I'll write tan of L. Tan of L is opposite, so square root of 77 over 2. I take out my calculator because it wants nearest hundredths. So here is my calculator, and I just type square root of 77 over 2. And I get 4.387. That 7 means that 8 is going to turn to 9. So 4.39. Now before we go on to the next, there's a word. The pre-calc kids already know it, or the calculus kids already know it. There's a word called truncated. If it were to say to the nearest hundredths truncated, not rounded, you would have said 4.38, whatever digit is there on the second after the decimal. Cool? So we just increase, hopefully, your vocabulary. So when you have physics with Mr. Wentz, and he tells you, oh, round to, or give me to the hundredth digits, raise your hand and be like, Mr. Winners, would you like it rounded or truncated? And, you know, he'll tell you what's up. All right, next one, guys. Sorry, I'm actually picturing Mr. Winners like, all right. Triangle ABC, the measure of angle C is 90 degrees, CB is 3, BA is 5, AC is 4. What is the value of cosine B? So notice they don't give you any images now like yesterday. So you just draw a right triangle, guys, and it's not going to be to scale. None of these triangles are to scale if you want to put not to scale. What's important is where the 90-degree angle is at. So where the 90-degree angle is at, label that vertice C. And then the other two vertices, it doesn't matter. You can label the top vertex A or the top vertex B, it doesn't matter. And then just, this says CB is 3, so 3. This says BA is 5, so 5. And the AC is 4. So I have a 3, 4, 5 triangle. Obviously, it doesn't look like it. I mean, because of the scale, but that's fine. And I already forgot. What do they want? Oh, yeah, cosine of B. So here's my angle. And I'm going to write SOHCAHTOA. And I'm looking at C. So I'm going to write cosine of angle B is equal to, cosine is adjacent over hypotenuse, 3 over 5. They don't really care about what value. It doesn't say nearest hundreds or nearest anything, so there it is. If it did say nearest thousandths or nearest hundredths, we would say 0.60. I'm not a big fan of that, but that's fine. If it were to say that. It doesn't say that. Bless you. All right. I think we're good. Let's go to the next one, guys. So the next one says in triangle ABC, the measure of angle C is 90 degrees. So that's the important part there. So let's label the 90-degree angle vertex C. And it doesn't matter. We're going to mix it up. I'll label that B and this one A. It doesn't matter which one is what. CB is 36. So CB, 36. BA is 85. BA, 85. AC is 77. The hypotenuse is always the longest side. And it says, what is the value of tangent of angle A? So I look at angle A. Here's angle A. And if you want, you can write SOHCAHTOA. So tangent is opposite over adjacent. So I'm going to write tan of angle A is equal to 36 over 77. How do we feel so far, guys? They want it to the nearest hundreds. So I take my calculator and I just go 36 over 77. So 0.47. I don't see any mistakes. I think we're good, guys. All right, let's keep going. Don't worry. Here's where it's finally going to get better. So check it out. Now they're going to get fun. After this, they're going to be like super fun. I don't know about Fiesta Texas fun, but it's going to be fun. In triangle QRS, the measure of angle S is 90 degrees. So let's draw a right triangle. And this one's the important vertex. So angle S is 90. And it doesn't matter where you put Q and R. And it's not to scale, of course. And it says angle Q is 61 degrees. So I write 61 degree there. And it says QR is 79. All right. Write SOHCAHTOA here. Here's how you solve this. Notice what they want. Find the length of RS to the nearest foot. I'm going to put X. Here's how you solve these questions. These are very popular in the SAT, ACT. With respect to 61 degrees, is the X opposite, adjacent, or hypotenuse? Opposite. What about the 79? Hypotenuse. Which one uses opposite and hypotenuse? Sine, cosine, or tangent? Yes, the sine. Do you guys see that? So you're going to write sine, and you have an angle this time. That angle is 61, so type that in there. Equals X over 79. You're actually going to be doing this a lot in physics. A lot actually, like so much, and you're learning it now. So, how do I get the X by itself? You just multiply this side by 79. Whatever you do to one side, you do to the other. So 79 sine of 61 degrees equals X. You take your calculator. You make sure that your calculator is in degree mode. And how do you know? Well, in Desmos, it tells me right here. See, it says DEG. That stands for degree. So, and I already forgot what it was. What was it? 79? Was it 79? Sine of what? 61. And there's my answer. So 69.09. Did they want it to anything specific to the nearest foot? So 69 feet. If there's units, put units. How do we feel, guys? Awesome. So we're going to do some more of those. So if you go to the next page, first thing I do is I write my abbreviation or your acronym, SOHCAHTOA. It says round to the nearest tenth to solve for x. So I look at that 34 degrees and I say, with respect to 34 degrees, is the x opposite, adjacent, or hypotenuse? Opposite. What about the 6.7? Adjacent. Which one am I going to use? Tan. So I'm going to write tan and put that degree there, 34 degrees, equals opposite x over 6.7. I'm going to multiply by 6.7 times 6.7 times 6.7. Whatever you do to one side, you do to the other. 6.7 tan of 34 degrees will give me my x value. I go to my calculator and I just type that in. 6.7 tan. I already forgot the degree. What was the degree? 34. And there it is, 4.51. Did they want it to the nearest tenth or nearest hundredths? 4.5. And that's it, guys. How do we feel? I like to do 3 examples. I think I have one more. Well, actually, we're going to do 2 more. I'm going to make one up because there's a certain scenario that we haven't done. All right. So again, I write SOHCAHTOA. So let's try to save some space, guys. Try to save like half the space because I want to do a new one on the right side. So with respect to 67 degrees, is that x opposite, adjacent, or hypotenuse? Adjacent. What about the 85? Which one am I going to use? Cosine. So you're going to write cosine of 67 degrees equals adjacent x over 85. Again, just like the others, times 85, times 85. So let's see what we get. 85 cosine 67. 85 cosine 67. 33.2. Cool or not cool? All right, so let's draw another triangle, guys. And this time, let's see. Let's make this up. 25 degrees, 10, and x. It is a unique scenario. So how is this different than the others? Well, in this one, guys, with respect to 25, that 10 is still opposite, that x is still hypotenuse. Which one uses opposite and hypotenuse? So that is nothing different. So sine of 25 degrees equals opposite over hypotenuse. Now you notice that x is in the bottom. So catch up to here. Now that we know that x is in the bottom, you still solve it the same way. If you're super advanced, because you've done this many times, you can just toggle the x and the sine 25. But relax, we'll get to it right now, how we do it. So how do we solve for x? Well, first we got to get rid of that x in the bottom. Times x times x. Times x times x. So now we have this. X sine of 25 degrees. So the sine 25 is all together, right? Equals 10. Now I have x times sine 25. To get x by itself, I have to divide. Divide by sine 25. Whatever you do to one side, do to the other. So now you can see x is just going to be 10 divided by sine 25. So you could have just, if you wanted to go fast. So I take my calculator and I go 10 divided by sine 25. 10 divided by sine 25. Enter. And I got 23.66, so let's go 23.7. 23.7. And there it is. By the way, guys, just an observation. Notice that on none of these, could you have used Pythagorean theorem to solve for x? No, because they don't give you two sides, or they don't give you two sides of 3. So you couldn't have used Pythagorean theorem. All right. So put your pencils down, just listen and observe 100%, because we're going to talk about inverses, and this is a pre-cal topic, but we're going to do it so fast. It's not an actual lesson. We're just going to talk about it. So hopefully we know something from geometry. Hopefully we'll see. So if I told you, so don't write anything down, just listen. If I told you 5x equals 15, yes, I know you guys can tell me that x equals 3. You would say, if I were to tell you, show me the steps, you would say divide by 5, divide by 5. But what if I told you you cannot divide? You can't divide. I want to see everything as a product. I want you to isolate the x. So in order to do that without the actual expression of a quotient, of a division, you would multiply by the reciprocal. And I know a reciprocal is not the same as an inverse, bless you. A reciprocal is not the same as an inverse, so let's not get that confused. But the concept is the same here. So when I do that, you get the x by itself, and you would get 15 times the reciprocal of 5. Cool? And maybe you're thinking like, Chavez, I don't know what you're talking about. I have no idea what you're saying. All I'm doing is, remember that this means 1/5. So it's like taking 1/5 times 5, and the 5 goes away, right? So 15 times 5 to the negative 1 is 3. And if you don't believe me, here is my calculator. So 15 times 5 to the negative 1. And there it is. You get a 3. Cool? Now, I don't know. Maybe Dr. George would be upset of me trying to teach you this way. This is not a full-blown lesson. Reciprocals are not the same as inverses. This is a reciprocal. They're not the same as inverses, but the concept for this is the same. If I have something like tan theta equals, and I'm just going to make up a number that I know is a perfect angle, square root of 3. If I want to get the angle by itself, if I want to figure out what theta is, I need to do the inverse of whatever I have on the left-hand side. Does that make sense? Similar to what I did here, and I guess you could call that an inverse, but the correct expression is a reciprocal for numbers. So how do I get theta by itself? I do a, say it with me, inverse. So here it is. If I want theta by itself, theta equals the inverse of tan. And that's how you say inverse tan. You put a little negative 1. Do you see how the concept is kind of similar? So you put a little negative 1, and then what do I have on the inside? Square root of 3. I type that in, and you're going to get an answer. Do you guys pre-cal people remember? Y divided by x? It's okay. It's okay. I put you guys on the spot. It's 60 degrees, but don't worry. So check it out, guys. Arctan, here it is. And I'm just going to type in square root of 3. Square root 3. And you get 60. Cool? And don't worry. You will know all of these when you get to pre-cal. And we're going to really know them like crazy. That's a special number. It's not always going to be special. Not these. These aren't special numbers. So anytime we want to get the angle by itself, we do the perfect. So that's all you have to do. You don't have to write anything down, just as long as, or if you want to write that concept real quick, I guess I'll write it here for good notes. To find the angle in an expression like sine theta equals half, ... take the inverse to find or to isolate theta. There, for good notes. This is not the perfect, these are not perfect notes, but they'll work for now. To find an angle in an expression like sine theta equals half, take the inverse to isolate theta. And they'll work for now. All right, so here we go. You guys ready? It says solve for x, round to the nearest tenth of a degree. So I'm going to write SOHCAHTOA. Solve for x. So x is a degree. With respect to x, is that 50 opposite, adjacent, or hypotenuse? Opposite. What about the 36? Which one uses opposite and adjacent? So we're going to write tan x equals 50 over 36. And yeah, you can reduce the 50 over 36, but just leave it alone because we're not interested in that. So how do I get x by itself? I do the what? The inverse. Perfect. So this is inverse tan. You can also say the word arc tan. It means the same thing as inverse. So there it is, inverse tan, and I just type that into my calculator. So I take my calculator and I go arc tan. Chavez, where's arc? You got to click on function. So go to function on this one, and then there it is, arc tan. And I already forgot the number that was inside. What was it? 50 over 36. 50 over 36. And there's my angle. 54.24. Did they give me any directions, like nearest tenth or something? Nearest tenth. So 54.2. So x equals 54.2. Put the little degree symbol. Without the degree symbol, it's a radian. But for now, we're not being too picky. Later on, we will though. But for now, we're good. How do we feel? All right. Let's go to the next one. Solve for x. Again, it's the same thing. It's a degree as well. You could, if you wanted to, find this. Maybe we'll find it. I don't know. See if we get the same thing. So with respect to x, that 84, is it opposite, adjacent, or hypotenuse? Adjacent? Yeah, it's adjacent. What about the 98? So which one can I use? Yeah, cosine. So we're going to write cosine of x equals 84 over 98. And yeah, we're aware that we could reduce it, but we don't care. Because we're not interested in that. We're interested in the angle. So how do I get x by itself? Inverse. So here's how you say inverse. You can also say the word arc cosine. A-R-C, it means inverse really. So cosine of -1, put the little -1 there. 84 over 98. And that will give you your answer. So let's go ahead and see what that is. 84 over 98. Arc cosine, go to function. Arc cosine, 84 over 98. 31 degrees, guys. 31.0. Cool or not cool? Don't worry, we're almost done, guys. Check it out. We got one more. And then we got real good ones. We got some word problems. So with respect to x, again, that 0.4 is opposite. What about the 0.5? Hypotenuse. So which one uses opposite and hypotenuse? Sine. So we're going to write sine of x equals 0.4 over 0.5. And I know it's weird to have a fraction with a decimal in there. I think they call that improper, but don't quote me. So there it is. You can say 4/5 really. And then inverse, x equals arc sine 0.4 over 0.5. And let's see what that is. Hey guys. So I take my little calculator and I go arc sine, and really you can just write 4 over 5, but you guys do 0.4 over 0.5 and see if you guys get the same thing. Did you guys get 53.1? Okay, I hope so. Is anyone trying it out? 53.1. All right, guys, I think we're good. Once you know that, you can tackle word problems. So check it out. Look at this word problem here. I think we finished all of them, right? So we're on the last page. So all we really need to know is what does angle of elevation and angle of depression means. So remember, angle of elevation with respect to the horizontal, that just means like how many degrees you go up, right? And then angle of depression with respect to the horizontal is like how many degrees do you go down with respect to the horizontal. So that's all you got to know. So you guys might remember this question because I literally just copied and pasted it, but the other two questions are fresh. So you'll remember one, and then the other two you're like, what? You've never seen before. So here we go. There's a real question, guys. Interstate 5 in California enters the San Joaquin Valley through a mountain pass called the Grapevine. So if you didn't know, now you know. Cool, right? Okay, I think it's cool. The road descends from an elevation of 3,500 feet above sea level to 700 feet above sea level in a slant distance of 5.5 miles. Approximately what angle does the roadway make with the horizontal? Okay, if you have to read that again, read that again. I like to make little pictures, so I write 3,500 and I put a point, a vertical, and I know that my vertical displacement, I went down 700. I went down so many feet and I got to 700. So right here at that moment, I'm at 700. So I know that I got to find the difference of that, and we'll find it right now. And here's my right angle, and this road, and I know it's not a perfect slant, but I'm going to say that road is 5.5 miles like that. And it wants to know what angle the road makes with the horizontal. Well, there's my horizontal line, so they must be talking about that angle there. That makes sense, guys? And then they're nice to us. They told us that 1 mile is 5,280 feet. Did you guys know that? What do I need to do? I need to figure out that vertical displacement in feet. This is feet, this is feet. Subtract 700 from 3,500. 2,800 feet. And I don't want that in miles. I need to have the same units. So either I convert the feet to miles or I convert the miles to feet. Which one do you think is better? Feet to miles? We can convert the 2,800 feet. It doesn't matter. Oh, the 5 miles to feet? Okay, 5.5 times, what do I got to do? 5.5 times 5,280. That's a number, and I do not know what that number is. Close to 30,000. 29,040. Nice. Nice. All right. So now we got that. With respect to this angle, is the 2,800 opposite, adjacent, or hypotenuse? Opposite. What about the 29,040? So which one am I going to use? Sine, cosine, or tangent? Sine. So I'm going to write sine of this angle, that's what we're looking for, equals 2,800 divided by 29,040. How do I get theta by itself? Do the what? Inverse. Arc sine 2,800 divided by 29,040. Yes, ma'am. Yeah, go for it. Yeah, go for it. Sorry, miss. I'm going to take my calculator. Arc sine. No problem, miss. 2,800 divided by 29,040. 5.5 degrees. That's actually pretty steep, guys. TBH. Theta equals 5.5 degrees. Cool? Yeah. I thought that was pretty cool. Let's do two more. Two more word problems, and then we'll do some delta. Winters wants to use a sheet of fiberboard 30 inches long to create a skateboard ramp with a 19-degree angle of elevation from the ground. He looks like a skater guy. How high will the ramp rise from the ground at its highest end? Round your answer to the nearest tenth of an inch. Okay, so here's what I understand. I have the floor, and I have a ramp. That ramp goes something like that, and it's 30 inches long. And then I want to know how high you are up from that. So here's my right triangle. I want to know that distance here. I know that this angle here is 19 degrees because they tell me that's an angle of elevation, which means going up on the ground. How do we feel? Perfect. So with respect to that 19 degrees, is that x opposite, adjacent, or hypotenuse? Opposite. What about the 30? So which one am I going to use? Sine. So I'm going to write sine 19 degrees equals x over 30. Now we're just going to multiply by 30. So 30 sine 19 degrees equals x. And you're actually going to be doing that a lot in physics, guys, to figure out forces. So here we go. I go to my calculator, make sure it's in degree mode, 30 sine 19, and I push enter. 9.76 inches. They said near a tenth of an inch, so 9.8 inches. Cool. Let's do one more. From a hot air balloon, Delmer measures a 33-degree angle of depression to a landmark that's 1,579 feet away, measuring horizontally. What's the balloon's vertical distance above the ground? Round your answer to the nearest tenth of a foot. All right, so it helps to draw a picture, guys. So here's a hot air balloon, and we're just going to say the angle of depression is from the center of that balloon. And here's the ground. And I don't know, she's looking at something. Let's say there's a building here. We're just gonna make a stick. Guys, I got a D in art, so you gotta give me some slack here. All right, are we cool? So let's see. Angle of depression of 33 degrees. So go ahead and from the center of that, here's my triangle. Oh man, that's supposed to be the hypotenuse, but I didn't do a good job. And here's my horizontal. So that means this is 33 degrees right there. I put 30, but I meant 33. Does that make sense, guys? All right, and then I just do this. So there it is. This is the triangle that I'm looking at. In blue, there's my right angle. The horizontal distance, and I'm going to draw this in black. Do you guys see that triangle in black? Okay. The horizontal distance is 1,579, but because this distance here in dash in black, that should be the same as this blue line solid up here, no? Perfect. And there you can work with the black dotted triangle if you want, if you feel confident, but I'm just going to work with the blue one. Is that okay with you guys? All right, so here we go. What do they want? The vertical distance, so sometimes they call that the vertical displacement. So with respect to the 33 degrees, is that x opposite, adjacent, or hypotenuse? Opposite. What about the 1579? Adjacent. What am I going to use? Tan. So here we go. On the side, I'm going to write tan of 33 degrees equals opposite x over 1579. Again, you just multiply both sides by 1579 to get x by itself. So 1579 tan 33 degrees equals x. And I type that into my calculator, guys. So here we go, 1579 tan 33. 1,025.4. 1,025.4, and I need units. Feet. Do you guys feel pretty confident? So do you guys feel like you have raised your SAT, ACT score at least a few points just in the last 2 days? Yeah, now you'll get these questions correct when you see them, guys. All right, so practice makes progress, guys. Go ahead and log into Delty. And it looks like a lot. It's actually not the whole.